Alright, we are ready for acid-base titration 2. So this is experiment 13 in the lab notebook. Alright, so here we have a volumetric flask. So a volumetric flask has one mark on it. Alright, I don't know if you can see that mark. It has one ring. It is right there. And that is the only mark on a volumetric flask. So these are very accurate. This is a 100 ml volumetric flask. When you raise the volume to this mark and you want to have the meniscus, the dip in your solution, all right, and you want that meniscus to be the bottom of that meniscus right on that line, and you will have 100.00 milliliters of solution. Alright, so I put in the oxalic acid. I weighed out 0.3226 grams of your oxalic acid. Now, oxalic acid is a hydrate. So it has coordinated to it two waters. And so that makes the molar mass 126.07. And so we're going to calculate this molarity when we do our calculations. But right now, there is still some solid at the bottom, all right, and I am dissolving all of that solid. So in a volumetric flask, I filled it up a little more than halfway. Then I quantitatively added the solid, and I rinsed out the weigh boat and made sure that all of the solid was quantitatively added to this volumetric flask. All right, and then I'm going to swirl it. If you fill it up too high, you're not going to be able to swirl it. All right, and so you are going to then swirl this until it is all dissolved, and it looks to be completely dissolved. All right, and so then you get your squeeze bottle of deionized water. All right, and you're going to add your deionized water until it reaches that mark, and then you will have 100.00 milliliters of solution. Solution includes both the solute, and that is our oxalic acid, and the solvent, which is the water. Alright, so they are mixed together. Now, you cannot pass up the mark. If you pass up the mark, then you're going to have to re-weigh out your solid and do it again. And I don't want to do that. So we are going to slowly add the water until it reaches the line. Alright, and so my meniscus is right on the line. I don't know if you can see that, but the meniscus is right on the line. So I have 100 milliliters of solution. Now it has to be mixed. In the directions it says to put a cork on it. Alright, I don't have a cork. The corks either fall through, they break in half, and we have all kinds of cork problems. So what I have changed it to is to get a dry beaker. All right, and so we can't mix this and get a homogeneous solution. So we're going to pour it into a beaker where we can swirl it, and we're going to put that in our burette. So we want it in a beaker anyway. It doesn't pour well out of a volumetric flask. So we have exactly 100 milliliters and 0 completely bone dry beaker. And so now I'm going to add it to this beaker, and it is mixing as it goes in. And so now you have a solution. It is a homogeneous solution. Alright, and so you can give it a little swirl, except beakers are not made for swirling, and we will not be doing titrations in a beaker. This is for storing our solution and pouring it into our burette. Now, just like we did for acid-base experiment 1, acid-base experiment 2, we have to thrice rinse our burettes. All All right, and so make sure the stopcock is closed when you add your 5 mils. All right, and so we're going to add our 5 mils of our acid. All right, and then we are going to clear out the bottom, rinse that, rinse the sides. All right, so that is the first rinse. We're going to thrice rinse it. So here's the second rinse. Put in 5 mils, open up the stopcock, let it run through, the rest comes out the top, and getting all the walls of your burette wet with the acid solution. Again, clear out the bottom, and then the third time it is then thrice we're going to rinse this. Another 5 mils, rinse it out the bottom, bottom's all rinsed out. Get the sides of the burette walls all mixed in with this new acid solution. And then open up the stopcock, and now we have a thrice rinse. So it is wet, but it is wet with the correct concentration, the exact concentration that we made of our oxalic acid. All right, and so now we're ready to fill it up. We have to get rid of our air bubbles again. So having it in a beaker is very nice for filling up your burette. Alright, so we open this up, get all the air bubbles out of the bottom. So there was air bubbles in here, we had to push all of the air out. And in doing so, we need to fill this back up. Alright, great. All right, and so again, we have some air bubbles. If I can find my handy dandy rubber stopper to get out my air bubbles. Not sure where I put that. All right, maybe my finger will do the job. So we have a few air bubbles that we have to tap out of here. Well, I can't blame anybody from taking that from me because I'm the only one here. All right, so I'm not sure where I put that. And my finger is not doing the trick, so I will get this one, which is not as good as the other one. And I will hit it with the... Oh, that did the trick. All right. There's one down here. All right, all the air bubbles are gone. All right, so now we are ready to put that back up. And I'm sure you've noticed that I didn't wear my safety glasses. I was waiting for somebody to yell at me to, hey, they're not here to protect your chin. They are here to protect your eyes. All right, so we now have our safety glasses on. All right, and so we have our oxalic acid and we have our sodium hydroxide. So if we are then reading along in our experiment 13, there's a lot of things that I already did. I measured out the oxalic acid, I put it in the volumetric flask. We're going to use the NaOH solution from experiment 12, so I've got that still in the burette ready to go. And I thrice rinsed my burette, and now I just need to take an initial reading for my acid. And so my initial reading for the acid is 0.11. So I have 0.11 mils of my acid. All right. All right, so we're going to deliver about 25 mils of the oxalic acid. So it says about 25. I'm going to add about 23 or 24. This is a liquid, just in case we pass up the end point. We can then back titrate and take our final volume. If you add the 25, you can't go below 25. You would have to start over. So I'm going to add about 23 to 24 mils. And I have a new burette here that's adding very fast. Alright, so I've stopped it right at 23.5. Let's get that accurate measurement. Alright, so that is a 23.55. So 23.55 is our volume of our oxalic acid now. Alright, so then we add our 4 drops of phenolphthalein. So we have our phenolphthalein indicator. Four drops of phenolphthalein. And now we're ready to do our titration with our NaOH. We'll get the book again, so it has, possibly you can see the color. Alright, so the same thing, we need our initial volume, and this is 0.01 mil. For our NaOH is our starting volume. Alright, and again we're going to add this, let's make sure we, before we add it, okay, that's right, add 4 drops, yes, okay, that's what we're doing. Making sure they didn't want us to add any more deionized water. Okay, so now we're adding our NaOH. A little slower than that. Again, if we pass this one up, it's not that big of a deal because we have another milliliter at least on this side that we can do a back titration. So anytime you pass up a titration and you have to add more acid in this case, because we're adding base here, if we added too much base, we would have to back titrate, which means add more acid. That would be a back titration. When you're doing solids, that is a problem because then you would have to weigh out more solid to do a back titration or get another liquid acid, and now you have 2 acids to deal with. All right. So when you have a liquid acid, liquid base in a burette, you can pass up the end point and it's easily back titrated. All right. So we can add this probably a little faster, since if we do pass it up, it doesn't matter. We have capabilities to back titrate. Very pink yet. Let's add it even faster. All right, now it's lingering a bit. We can slow it down a little bit. Again, for your titration, you would like it to have 1 drop. Goes from clear and colorless to a nice light pink, and the light pink has to stay for 30 seconds while swirling. Getting very close. Probably should slow it down. Now you want to add it when you're really close. You can add half of drops. You just have the drop come out, and then you can tilt it against the side. And again, the deionized water we tested is excellent deionized water. So we can rinse this down anytime we want. So we can grab our deionized water, rinse this down, anything on the sides, rinse it into it. All right. Very close. So we don't have to wait for the drop to hit. We can tilt it, hit the side, then it goes down the flask. Get our deionized water, squirt it down. All right, looks like we're going to need another drop. So again, you can make the drop come out. It doesn't have to all the way drip in. Hit it on the side. Get your deionized water. Squirt it down, give it a swirl. Nope, not yet. Very close. A drop or two is going to do it here. That might do it. Let's see. That is probably going to do it. We'll see if it lasts for 30 seconds. So we have a nice light pink, but will it stay for 30 seconds is the question. Looks like we're going to need a half a drop. It did not stay. So a half a drop, again, we're not going to let it drip all the way out. We're going to get some of the liquid out. It's like a quarter drop. Again, we tilt it on the side. And then you can actually, anything that's on the tip here also would count in our calculation of amount added. All right, let's see if this lasts for 30 seconds. All right, I don't know if you can tell, but it is still a light pink. And so this is a very, very, very faint pink. And so this is a good endpoint. It barely lasted the 30 seconds, but it did last the 30 seconds. Well, for good measure, we can make it to where you can see it better. And so we will again add another quarter of a drop. Even maybe a tenth of a drop. And so it is a nice light pink still, and still can't hardly see it. Let's make the pink to where you can see it, although this is like the perfect endpoint. But let's go ahead and add another drop. All right, so now you can see that much better that we have a light pink endpoint. All right, so now we're ready to get our final volume from our NaOH. All right, and our final volume for the NaOH is, let's see here, 17.88. So 17.88 is our final volume. All right, now we're ready to do an unknown KHP again. The unknown KHP, I picked a different unknown. Our unknown number this time is going to be 59. So 59 is our unknown KHP. We are not going to follow the directions exactly because it says to do 3 samples. We are only going to do 1 of each one. Again, you're not going to have to do any averages, standard deviations, anything like that, because you're not going to be graded on errors because I am doing the lab. All right, so for this one, we are just going to calculate our concentration of our NaOH, and then we're going to get another percent KHP for our calculations for this lab. I will get the unknown ready and do the last titration. All right, we are ready for our last titration in experiment 13, acid-base titration 2. All right, and here I have the unknown KHP. This is number 59, and I have measured out 0.4656. So 0.4656 grams of unknown KHP is in this flask, along with 50 mils of deionized water to dissolve the solid unknown KHP. I also added the phenolphthalein. Again, I don't have my safety glasses on. They're right here. All right, my safety glasses are now on. All right, and so once we have dissolved all of this solid acid into the deionized water, and we've added our 4 drops of phenolphthalein, we are then going to titrate this with our NaOH solution. All right, it is all dissolved. We are ready to do our titration. All right, now here is our solid KHP. Again, we do not want to pass up the endpoint. Again, the endpoint is where you stop your titration. The equivalence point would be the exact amount of acid and base. All right, the color indicator tells us when to stop. That is then called the endpoint. All right, so we need our initial volume for our NaOH. All right, then our initial volume for our NaOH is 0.80. So 0.80 milliliters is our starting volume for this titration. All right. So again, we do not want to pass up the endpoint. Anytime you are adding a solid, you want to make sure you do not pass up the endpoint. It's very difficult to add more solid to this. If you pass it up, you just have to restart the experiment. Again, we can add it slowly, and we will notice that the color will linger. Once I notice that the color is staying longer as I'm swirling, I know that I'm getting close to the endpoint, and then I can slow it down. But titration should be done drop-wise. This is an unknown. We do not know when it's going to change to the light pink. So we need to be adding it drop-wise. You don't pour in a bunch of volume and then swirl it. You add it drop by drop so that you have the, if you pass up the endpoint, it's going to be passed up by a drop, which will be fine. All right, the color is staying around longer. We're getting closer. It's taking a while for that pink to disappear now. All right, you better slow it down. All right, so now we're going to slow our drop adding. I guess I could have did this with a magnetic stirrer. That would have been easier for me. Maybe the next titration I'll use a magnetic stirrer. close here. I'm going to add it 1 drop at a time now. That's very close. Okay, I think we might have it here. As long as this stays for 30 seconds. We have our nice light pink endpoint. That is the color we're looking for, nice light pink. 1 drop changed it from colorless to a light pink. It is staying around for 30 seconds. We have hit our endpoint. All right, and so our volume of our base is 14.68. 14 point. No, it's not. It is 14.1238. 14.38. Sorry, 14.38. All right, now we will go through the calculations for acid-base titration 2. I'm going to clean this up and we will go through the calculations. All right, to calculate the molarity of your oxalic acid, you take your mass of your oxalic acid divided by the molar mass of the oxalic acid, and as a solid it is a dihydrate, and divide that by the volume of the solution, and that has to be in liters. So the numbers that we had, we weighed out 0.3226 grams of oxalic acid dihydrate, which then has a molar mass of 126.07. So if you just take 2 H's, 2 C's, and 4 O's, you do not get 126.07. You have to also take the 2 waters, and your molar mass is 126.07. And then divide that by the total volume in liters. We had 100 milliliters, which is 0.1 liter. And remember, when you had your volumetric flask, it was 100.00, which is 5 sig figs. And so make sure you're using your significant figure rules. So that's how you will calculate your molarity of your oxalic acid. All right, so now we did a titration. So we need a balanced reaction. And so here is the net ionic equation for the reaction of your oxalic acid with your sodium hydroxide. Note, oxalic acid is a diprotic acid. It has 2 hydrogens in front. And so to neutralize a diprotic acid, you have to use 2 moles of NaOH, or for your net ionic, just OH minus. All sodium salts are soluble. All right, and so that gives 2 waters and your oxalate ion. So we're doing a titration, the titration equation. When you have 2 liquids, remember we made our solution for our oxalic acid. And so we had 2 solutions that we did our first titration with. And so you have MV over C is equal to MV over C. Molarity of oxalic acid, volume of oxalic acid, the coefficient of your oxalic acid in your balanced equation. The molarity of your NaOH, or net ionic, molarity of OH minus, volume of OH minus, and your coefficient of your OH minus in your balanced reaction. All right, and so your molarity of your oxalic acid, we just calculated that. The volume was from the titration. The coefficient of your oxalic acid is right there, it's a 1. The molarity of your NaOH, or net ionic OH minus, that is what we are solving for. The volume of your NaOH, that is what we got from our titration, and the coefficient of your OH minus is in the balanced reaction A2. All right, and so you're going to calculate the molarity of your NaOH, and it should be very similar to the molarity of your NaOH that you got from acid-base titration 1, because we use the same base. All right, and the next calculation is exactly the same as it was in experiment 12. we are calculating the percent KHP in the unknown KHP. Again, we have a different unknown number. This one was number 59. And so our net ionic is exactly the same as it was before. Our KHP plus our NaOH. Again, net ionic. All salts of potassium are soluble. All salts of sodium are soluble. So we have HP minus a monoprotic acid, HP1H, plus the OH minus, and that gives us our water and our P minus 2. Alright, and so to calculate this, we take the mass of our KHP, which we don't know because it's an unknown KHP, which means it contains KHP and other things. So that is what we are solving for, the mass of our pure KHP. The molar mass of the KHP is 204.23. The coefficient of your KHP in the balanced reaction right there is 1. The molarity of your OH minus, that is what we solved just before with our titration of our oxalic acid. Now we know the molarity of the OH minus. The volume of your OH minus, that is what we used in our titration for our unknown KHP. And your coefficient of your OH minus, again, right there is a 1. And you're going to solve for the mass of KHP. In order to find your percent KHP, you take the mass of KHP that you calculated divided by the mass of unknown that we weighed out times 100, and you will have your percent KHP. All right. So units, make sure all the units are correct in your equation. All right. When you are doing this one where you have volume on both sides, as long as your units for volume are the same, they will cancel. Down here we do not have volume on both sides. We do not have volume on the left side. On the right side, in order to get moles, because mass over molar mass gives us moles, molarity times volume will also give us moles, but only if your volume is in liters. So make sure you're paying attention to the units. And that is the end of experiment 13, acid base 2. Alright, so back to our endpoint, the phenolphthalein. Alright, so here is our phenolphthalein, and you should know that what the pH is when phenolphthalein is a dark pink, or yet you need to know if this is an acid or a base. And in here you also need to know if this is an acid or a base, and it's kind of fun. You just add your, because phenolphthalein is in both of them, if you add your pink solution into the colorless solution, it will disappear and you have a colorless solution. So chemistry is fun. Enjoy chemistry. I enjoy chemistry. It is lots of fun.